Again, this is Mr. Bonet with AP Calculus AB, limits one-sided. Okay, so on the AP test, you're gonna see examples like these. These are piecewise functions. Okay, all of these functions are piecewise functions, including the absolute values. Okay, so how do we attack them? Well, we have to focus on the domain, meaning on the values of x for which this function is defined. So here, this piecewise function, I tell my students like an algorithm, right? Whenever x is greater than 1, you're going to choose this function. And whenever x is less than or equal to 1, you're going to use the bottom one. Okay? So that's how we're going to find these limits. So let's start with the limit from x approaching 1 from the right. When x approaches 1 from the right, we have to use this one because 1 from the right means that it's infinitely bigger than 1. So x greater than 1 establishes that. Okay? So you just plug in 1 into the top one. So 4 times 1 minus 2, that's 4 minus 2, which is 2. Now, when x approaches 1 from the left, remember this symbol here, this minus, is not an exponent of -1, it's just an exponent of negative, which means 1 from the left. So if we approach x from the left, we have to use the one that is less than 1. Okay? Not necessarily equal, but less than. So we just plug it into the bottom one. So 2 minus 4 times 1. That gives you 2 minus 4, which is -2. Therefore, if these two limits are not the same, then this limit does not exist. Okay? Now, a little bit on top in terms of this not the limit not existing. Here we have a jump discontinuity. Okay? So jump discontinuity happens when the two sides are not equal. Okay? Now f of 1, where is it 1 equal to 1? It's equal to 1 in this equality because of this equal sign here. So you just plug it into 2 minus 4x. So 2 minus 4, which is -2. Okay? Now, this means that this function is continuous from the left. Continuous from left at x equal to 1. Right? Because that means that the limit from the left and evaluated at 1 are equal. So it's a jump discontinuity at 1. Let me write that down. But it's continuous from the left at 1. Okay? Now let's look at another example. Again, if you're looking for x approaches 1 from the right, you're looking for the inequality that says x greater than 1. In this case, the first one. So 3 minus 6 times 1 is 3 minus 6, which is -3. If you're looking for when x approaches 1 from the left, you plug it into the inequality that says x less than 1. So you plug it into this one. 1 squared, which is just 1. Again, since these two are not equal, then this limit does not exist. And then at 1, notice that the x equal to 1 is -1. So again, you have a jump discontinuity at 1. And you have no continuity from the left or from the right because none of these are equal. Perfect. Let's keep going. When t approaches 2 from the right, again, same concept. You just plug it into the one that has t greater than 2. So this is going to be 3 times 2 minus 1. It's going to be 6 minus 1, which is 5. t from the 2 from the left, it's going to be this one here. It's going to be 1 plus 2 times 2 gives you 1 plus 4, which is 5. Since the limits are both equal in both directions, then it's equal to 5. Add 2 is equal to negative 5. So notice that t equals 2 equals negative 5. Therefore, you have a removable discontinuity. Removable. At 2. Okay? So what does that mean? That the limit does exist, but at the point is not equal to the limit. Therefore, it's removable discontinuity and no continuous from the left or from the right. Okay? Next one. 3 from the right. Notice that they changed the inequality, so be careful with that. That's going to happen. They can write these inequalities whatever order they want, so you have to be aware of that. So you got to plug it into this one because it's x greater than 3. So 9 minus 3 squared gives you 9 minus 9, which gives you 0. 3 from the left is the top one. So again, 3 squared minus 9. 9 minus 9 equals 0. The limit does exist and it's equal to 0. At 3, notice that it says it's equal to 5. So we have a removable discontinuity at 3. Okay? Now, this one is a little bit different because it doesn't look like a piecewise function, but it is, right? Because by definition, an absolute value is a piecewise function. It's going to be 3t minus 6 for x. This case is t. Let me erase that. For t greater or equal. Now, what determines the value here is going to be the zeros. So what number will give me 0 if I plug in for 3t minus 6? Well, in this case, 2. And then negative, you got to put the parentheses 3t minus 6 for t less than 2. But notice that 2 is where they want us to find the limit. Okay? And it's specifically because that's where it gives you your different values. Okay? Now that you've written it like this, okay, you wrote it like this, man, my English is not perfect. Let's find the limit. So when t approaches 2 from the right, you have to use this one. So it's going to be 3 times 2 minus 6. That gives you 6 minus 6. That gives you 0. If you approach from the left of 2, you use the bottom one. So it's negative 6 minus 6, which is just 0. The limit does exist and it's equal to 0. And at 2, notice that the equality is the top one. It's also 0. So this one is continuous at 2. Okay? And why is that? Because all these 3 values are all equal. That's what makes it continuous. Now here we're going to have a problem because now we are dividing by x. Okay? Therefore x can't be 0 by definition. So here we have not defined, undefined. Okay? Because we can't divide by 0. Now let's try to find the limit. Well, same deal with the absolute value. Okay? You're going to write positive 3x over x for x greater or equal, well, greater in this case of 0, and negative 3x over x for x less than 0. Now notice that that can be simplified. X over x is just 1, so x greater than 0, and negative 3 for x less than 0. So notice that that covers up the limit really quickly. When x approaches 0 from the right, it's just 3. when x approaches 0 from the left is -3. The limit does not exist, and you have undefined. So this is a jump discontinuity at 0, and no continuous from the left or from the right. Okay? Now, let's change my color here. For this one, notice that, again, the definition only applies for the absolute value, not for the -3. So it's going to be -2z plus 4. Let me fix that. -2z plus 4 minus 3 for z. Well, what value gives me 0 inside the absolute value? That's equal to 2, so greater or equal than 2. And then negative outside, -2z plus 4, only on the absolute value, -3 for z less than 2. Okay? Now, let's find the limit. When z approaches 2 from the right, we're going to use the top one. Notice that 4 minus 3 is 1, so it's going to be -2 times 2 plus 1. That gives you -4 plus 1, which is -3. From z, from the 2 from the left, you're going to use the bottom one. And again, in order to find this, you got to distribute this negative in. So I'm just going to plug it in directly. So -2 times 2 plus 4 minus 3. That gives me -4 plus 4 minus 3. That gives you -4 plus 4 is 0 times -1 is -0, which is just 0, minus 3 is -3. Okay? Then the limit does exist because it's equal to both. Okay? So it's going to be -3. And then at 2, we choose the top one, which is also -3. So this is continuous at 2. Perfect. Now let's finish it up with these two. Again, same principle. Here we don't have options, okay? Therefore, we have to be careful. If it's an absolute value and it gives you 0 over 0, then my suggestion will be divided by 2 pieces. So what do I mean by that? Well, I make the argument that it's x over x for x greater than 0. Notice it can't be 0. And negative x over x for x less than 0. And again, you can simplify that. 1 for x greater than 0, -1 for x less than 0. So notice that the limit when x approaches 0 from the right of x over absolute value of x is equal to +1. The limit when x approaches 0 from the left of x over absolute value of x is equal to -1. Therefore, the limit when x approaches 0 of x over absolute value of x does not exist. Now, for this one, it's tricky because if you plug in 1, you get 1 over 0. Okay? Now, 1 over 0 is undefined, right? But in the limit, we can find what the limit is by plugging from the right of 1 and from the left of 1. Okay? So, let me use a different color. I've been using already a lot too much peach. Oh, thank you. So, when x approaches 1 from the right of 1 over x minus 1, what is that equal to? Well, technically speaking, it's going to be 1 over, if it's 1 from the right, then a number bigger than 1 minus 1 is going to be a number it's going to be a positive number. I'm going to call this positive number 0 from the right. Now, this 0 from the right, 1 over 0 from the right on the limit is equal to +infinity. Now if we do the same thing from the left, the same principle gives me that a number smaller than 1, this is going to be negative, so I'm going to have 0 from the left. And in the limit, this is negative infinity. Therefore, since those two infinities are not the same, this limit does not exist. Okay? In order to exist, it has to give you both positive infinity or both negative infinity. Okay? That is all for today. If you like the video, subscribe to Motivao, share with your friends, and I hope it was useful for you. Thank you.